Alright, so today we're going to take a look at adding together integers and collecting like terms. Now if we take a look at some examples, for instance, let's take a look at -8 plus -3. One thing we always want to keep in mind is if the signs are the same, we're going to find the absolute values of the two numbers. We're going to add them together. So in this case, the absolute values would be 8 and 3. Which is 11. And since the signs are the same, they're both negatives, our answer would be -11. So if the signs are the same, we find their absolute values, add them together, keep the sign the same for the answer. In this example though, I have -7 plus a +2. I still want to look at their absolute values, 7 and 2. However, this one's a negative and that one's a positive. So now I want to find the difference of their absolute values. The difference of the absolute value of 7 and 2 is 5. And now I want to take the absolute value, and now I want to keep the sign of the larger absolute value. Well, 7 was a larger absolute value, so the sign is a negative. If I take a look at this example, +4 plus +5, I can see the signs are the same on both of them, so I take their absolute values, 4 and 5, which is 9. My answer is going to be positive. And the last one, -5 plus a +5. Signs are different, so I want to find the difference of their absolute values. Well, the difference of 5 and 5 is 0. So now let's take a look at something a little different. Let's take a look at some terms, and let's identify their coefficients. If I had this term, x cubed y squared, I want to look at the coefficient. Coefficient is always the number that comes at the beginning of the term. You might say, well, there is no coefficient here. Well, there's always that implied 1 that comes at the beginning. So the coefficient here would be a +1 actually. We don't write the implied coefficients now, whether it's a positive or a negative, but it's always there, even if we don't write it down. Now if I had this, our coefficient would be a +4. 4y squared, coefficient, number before it is a 4, so our coefficient is +4. If I had a 3xy, the term is 3xy, the coefficient, number comes at the beginning, is 3. So our coefficient is a +3. So we're looking back here again, we had +1, +4, and +3. Now let's look at collecting some like terms. Let's look at this. 4x plus 3 minus x plus 6. Now the thing with collecting like terms is we always have to make sure we have a like set of variables. So variables have to be the same, exponents have to be the same. So when we go to look at these terms, one thing you want to do, or one thing that is always good to try to do, is if you use the commutative property, you can reorder them so that they are grouped according to like terms. So here I have a 4x, a -x, those would be like terms, and then I have a +3, and a +6, those are like terms. So if I was to reorder this, I would write it as 4x minus x plus 3 plus 6. So that's how I would reorder this, so that it's like terms grouped together. If I was then to go through and solve it, 4x minus x, remember this is minus 1x. That implied coefficient's always there, even if we don't write it. So it's 4 minus 1, that's 3. Variables stay the same, they don't change, so it's 3x. +3, +6 is +9. 3x plus 9. If we were to look at another example, let's say 6x plus 2 minus 2x minus 5 this time. Again, let's look at what our like terms are. 6x, negative 2x, those are like terms. Positive 2, negative 5, those are like terms. If we were to rewrite them so they're grouped together, 6x minus 2x, positive 2 minus 5. If we were then to do some simplification, 6x minus 2x, 6 minus 2, 4x, again the x doesn't change, we're just dealing with the coefficients, so 6 minus 2 is 4x, positive 2 minus 5, signs are different so we find the difference of their absolute values, it's going to be 3, keep the sign of the larger one so it's negative 3, it's 4x minus 3. So that's a little bit about adding together integers and combining like terms.